Hello everyone. Today in this video we'll be discussing about a famous concept in operating system called LRU cache. So LRU stands for least recently used cache, which is a mechanism in operating system which is used in reducing page faults in the memory. So when CPU want to access main memory for some particular task, it goes to the main memory and try to get that page needed for the process. But if the page is not available in the main memory, the page have to be bring back from the secondary memory. So that that is known as page fault. So to minimize that page fault, we are using many kind of algorithms. So one of the algorithm is least recently used, which is called LRU. So in the cache, which is the fast accessed memory location, which is used by the CPU to transfer the word. As you can see from this block diagram, that will transfer the pages from the cache to CPU. So in this video we'll be discussing mainly about LRU cache and its implementation and how we can implement using C++. So basically after discussing like what is cache and why we use uh, in the CPU, so you can think the LRU cache is like, for example, if you are using something recently, for example, you went to a party, so you have some party wear, so you will have that dress in your wardrobe, but the regular dresses which you will wear in your house, in your home, that will be most recently used. So the party wear which is least recently used, because you don't know when you will be getting invitation for a party, so that is the dress is least recently used. So what is the most recently used? That is the normal dress you will wear in day-to-day basis. So that dress should be kept in front of you so that it will be easily accessible. So similarly in cache also we need to determine the page frames, pages, so that pages are mostly needed. So we'll keep that pages such a way that will be easily accessible, and the page frames which are not easily needed will keep out of the cache. After understanding the implication and the logic behind this concept, we can think how we'll implement this. For example, as I said, we need two things here. One is we know what is most recently used, and the other thing is which is least recently used. So the most recently used should be present in the head. So we'll implement this architecture, this LRU cache, using two data structure. One is hash table and the other is doubly linked list. For example, here in the diagram you can see this hash table is having some keys which are from key 1 to key 5, and 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 the keys are in the hash table, which is nothing but which is storing the nodes in the linked list. So that these nodes are actually our mem page frames, which is stored as a head to end, and these are stored from most recently used to least recently used. So the one for one example, if we take this n3 as one page frame, and we want to access this page frame from the secondary memory. For example, in this case, this is already present in the cache. So I have drawn a diagram to showcase it. For example, here the cache capacity is 4, so the cache won't be unlimited, right? In that case you will be saying like, we can put whole the secondary memory to the cache, then we can decrease the uh, time to get the page, but that is not implementable or feasible in real time, because cache memory are costly, which is that's why we need to use that in efficiently. So capacity is 4, so our n3 is available here, So there is some request from the CPU that we need N3 for this process. So our N3 will be coming to the head now. We have that node access here directly from the hash table. We'll get this node and we'll give to the CPU, and parallelly what we'll do, we'll just update this head to N3, and all other node will be like this. The order will be same, but just the N3 will be coming in the head. And this diagram I have tried to show how the links will be deleted between this, and a new link will be added from the head, and this will be become new head. So those who know how to implement doubly linked list, I will make some other videos on that, implementing a doubly linked list. But for now we can just think like we'll keep this N3 in the front, so it will be MRU, most recently used, and this node will be LRU. The other case can be that N3 is not available in the cache itself, and the cache is full. So in that case we need to remove something. For example, here our in the cache we can see the LRU, which is least recently used in N7. So this N7 is have to be removed because it is LRU, least recently used. So we'll keep this N3 from the secondary memory and we'll put in the head, and we'll modify head, and this will be the most recently used node, and just will update the link, and all the order will be same, and the N5 will come here and it will be LRU. So basically the hash table is having the address of these nodes. So for getting a node from the cache, which is directly order of one operation, we'll call this hash table, we'll get that node. To update it, we'll need to traverse, and we need to reorder the cache. So it will take order of max, in most case it will take order of in time complexity. After discussing this approach, I want to show you the code which I have implemented. So this is in the lead code. So you can see I have taken in C++, I have used STL, which is standard template library, and which is having, I am having this aim cap, which is the capacity which I'll be storing, and the map which is nothing but the hash table here, and int is the key, and list pair, the in the STL the list is internally implemented as a doubly linked list. So directly we can implement like this, and iterator is the pointer to that node, to the list pair. Pair means the key and the value, and I have added one aim list here. So there could be two operations here. One is put and get. Put means we'll add that node into the cache, and get means we'll have to have that data to the CPU. To uh, to put that data, what we need to check, we need to check if it is already there in the cache. So just will from the map hash table or the hash map, we'll just find the key if it's available. If the iterator is available, then what we'll do, uh, we'll do this operation. We'll take that node in the front of the front of the list. Directly in the list we can do splice. If you don't know what is splice, you can go through some of the documentation and you will understand that splice is nothing but we'll put the first iterator this to the front in the, and all the node will be same. And if the size is capacity, in my what is shown in the second case capacity, so my node is residing in the secondary memory. In this case directly I'll check, I'll delete the last back. So I'll delete the last key, I'll pop it and just I'll erase, and what I'll do, I'll just add the new this key value, and I'll just map it to the key. So it is a simple, in the using STL, it is a simple approach to uh, implement it. But if you want to do in the C or other without implement using STL or collection, it can we need to, what we need to do, we need to implement doubly linked list, then we need to modify the links, so that will take more time. And using STL, you can see it is the directly just we are doing it in the gate. What we'll do, we'll check if in the map, if we are having that page frame or not. If it's not there, If it's not there, so we'll return -1, then means it's not available. So if then what we'll do, if it's there, we'll just add it, we'll add that node in the front, in the front of the linked list, and we'll send the value. So I'll post all these links in the description. You can go through this and let me know if you have any doubt on that. Thank you for watching. Bye.